Okay, live stream is going. Admit. All right, so we've been talking about food webs and food chains, and now we want to look at an energy flow. I think we're just waiting on two more people. But I'm gonna go ahead and get started. All right, so everybody should be, and it's not published, so you can't. There we go. Now it's published. Okay, it's published now. All right, is everybody able to get in now? Yes? Okay. All right, so we have been looking at, and there's a lot of vocabulary words with this, so you make sure that we understand all the vocabulary words. So our producers are also called autotrophs, and these are called trophic levels or feeding levels. If we're looking at this diagram tells us a lot of things. So the primary producer, and it's the only producer, there are no other producers because none of the other levels will produce their own food. So again, this is about a feeding arrangement. Okay, let me stop and let this one in so I don't have to repeat. Okay, everybody's here now. All right, for those of you who just came in, good afternoon. We're in Canvas. We're on ecosystem energy flow. And we're looking at this pyramid. Now again, let me backtrack. We use a pyramid to represent where most of the organisms are, where most of the energy is. It's at the base of the pyramid, so that's the widest part. If you're looking at populations in society, there are far more plants than animals, and plants are our producers. Okay, they are the only ones that can capture energy from the sun. So our picture of the sun is important to this diagram because that's where the energy is coming from. And the producers are, notice it says 100%. So producers are able to absorb 100% of the sun's energy. And then notice it goes to 10%. And then it goes to 1% and 0.1% and then 0.100% by the time you get to the apex predator. So that's what we want to look at today. So I'm going to give you a few minutes to read this passage, and then we're going to be concerned with this 10% rule. This 10% rule is what explains why we're losing so much energy as we go up the pyramid. So take a few minutes to read this paragraph. I'm going to do attendance, and then I'm going to come back and we'll talk about this 10% rule. Okay? data. Okay. All right, attendance is done. Come back to this. Okay, I'm going to come back to sharing and want to point out some important things in the passage. Okay. For starters, and you should be taking notes, you need to be familiar with the term first law of thermodynamics. It's also called the law of conservation of energy. Okay. The first law of thermodynamics states that energy can neither be created nor destroyed. And what we need to remember is and all that means is all the energy that's in the universe is in the universe. And when we break down food, we're not destroying it, we're just changing it to something else. So this is why we're talking about cycles. Energy is cycled. So we went through all the different cycles, the carbon cycle, the nitrogen cycle, the hydrologic cycle. Everything is cycled. So energy, all the energy that's in the universe is just cycled over and over again. What we are mostly concerned with when we're talking about ecosystems, we're more concerned with chemical energy because that's the energy that is stored in the bonds of the foods that we make. So we are able to convert the radiant sunlight energy into chemical bond energy. And then that chemical bond energy is released when we are feeding. So when we digest something, we break the bonds down, we release the energy in the form of ATP, and we are able to carry out all of our life functions. And just minute, somebody. Okay. Good afternoon. All righty. So energy can only flow in one direction in an ecosystem. It does not flow backwards. So what this pyramid also is showing you is that it is not cycled within the system. Okay, so what is happening, how it gets recycled is the decomposers break down things that die, and then it is recycled outside of our feeding relationship. So it's going back to the soil. Once it's in the soil, the plant can then absorb nutrients again. Gases that are released can be recycled through the atmosphere again. Heat that is lost is recycled through the atmosphere, but it is not recycled through this system. In other words, the primary, secondary, tertiary consumers don't recycle the energy. Okay, once the energy has passed through these organisms, it has to be sent to soil where it dies, or heat energy that's lost. Okay, so that's what they mean by it doesn't go backwards. The cycle goes in one direction and one direction only. All right. So again, first law of thermodynamics, conservation. The sun is the primary producer of all the energy, and it is only captured through photosynthesis. Um, the we talk about limiting factors. This only happens, the sun is only shining in the daytime. So this activity of photosynthesis is strongest in the daytime. It is also affected by temperature. So the warmer the temperature, the faster the chemical equation goes. And which is why we have the seasons that we have. We Trees conserve their energy by dropping their leaves. We live in the temperate deciduous forest, and that means that um, the trees drop their leaves. They don't photosynthesize a lot during the winter because there's less sunlight energy. So they store the energy in the trunks of the trees and the branches, and they function off of that through the winter. And then when it starts to get warmer again, photosynthesis starts to activate, then the leaves come back. Okay, so photosynthesis is uh, temperature sensitive. It is also light sensitive. Those are two important limiting factors that regulate photosynthesis. All right, it says where, I'm over here on the next paragraph, where the process converts energy. All right, so that's a definition. I think maybe biology, you might have said the process where plants make their own foods. It's also, yes, they are making their own foods, but the important part for us right now is it's the process where plants convert light energy from the sun into chemical energy. So you've got to kind of fuse those two definitions together. Okay. All right. What else do we need to talk about? Okay, this is where we comes our 10% rule. We're going to discuss this part in the next section. So the plant, we were looking at our pyramid, the plant took in 100% of the energy and it creates a storage molecule called glucose. So it has stored 100% of the energy that it took in. But here it's saying it only passes on a fraction of it. And that's because the organism uses the energy that it took in for its life processes. So what is stored and what is available for the next organism that eats it is only 10%. Okay. So we're going to look at that, and there's a rule. So we're going to look at the 10% rule. The other thing that you need to remember is energy is measured in joules and kilojoules. So that is the unit for energy. So whenever you're doing problems involving how much energy is gained or lost, you have to express it in joules. Okay. Alrighty, so essential knowledge. The loss of energy occurs when energy moves from the lower to a higher trophic level and can be explained through the law of thermodynamics. Okay, and again, it seems like it's lost, it's just being used, it's being recycled. All right, all the ecosystems depend on a continuous flow of high quality energy in order to maintain their structure and function of transferring matter between the environment and an organism via biogeochemical cycles. So the biogeochemical cycles are the ones that we talked about earlier last week before, where we were talking about carbon cycles, phosphorus cycles, oxygen cycles, water cycles, nitrogen cycles. Those are the cycles that they're referring to as biogeochemical cycles. Okay, so let's look at this.
So this is going to be a little tricky because we don't have, but it's going to be what we know. So in this problem, it says that 2 million kilojoules of sun energy comes into the ecosystem. How much is available in the third trophic level? As assumed if plants only use 1% of the sun's energy. So I'm going to underline the important things. So we have 2 million kilojoules of sun energy.
All right, I want you to write this down because we're going to keep this as a sample question for you as you do, because you will have problems to work on. So let's write this one as a sample question. And again, she has measured the amount of energy coming from the sun in as 2 million kilojoules of energy. And this is what you need to do when you're reading these questions. You need to break them down. what is available, what information are they giving you, and what information are they asking you for?
third trophic level, and then we're assuming that things will use 1% of the sun energy.
Okay. So they're looking at, let me see if I can shrink this for a minute. When I say they're looking at the third trophic level, if we come back up here, the question is looking, this is the first, second, third. So this is the level that they're looking at, the secondary consumers. Okay, so again, you have to imagine that you have this pyramid in front of you. The producers are the first level, primary consumers are the second, and the secondary consumers are your third level. Okay. All right, so that's the third. Okay. And then she's saying, assume that the plant only used 1% of the energy that it got from that 2,000. I mean, 2 million.
So first we need to see how much of the sun plants will use. So we're going to need to multiply 2 million by 1%. So I'm and calculator that's this is what the plants have.
Okay, everybody got that so far? All right. So she just took the information from the problem, and they asked you to assume that the plant was only going to use, of all that energy, the plant was only able to use 1% of it. And everybody knows that 1%, and when you write it as a decimal, is 0.01. So now she has 20,000 kilojoules. Everybody good so far? Okay.
So this is what we got from the plants. So this would be basically the first trophy. So now we need to figure out the second trophy level. 10% rule, we say that only 10% passed on from one level to the next. So that we need to do 20,000 times 10% and 10% in a calculator. One, that's going to give me 2,000. So that's my second trophy level. Okay, and we want the third, so we need to do this one more time. Okay, so we're going to do 2,000 kilojoules times 10%, and that's going to be 200. So that's what is available in the third trophy level. So this would be like plant. This would be our, so that could be like, this could be something that like a primary consumer or a primary. So you can have like say a box. Like, and you can go up and up, right? Because something eat a box like a wolf or something like that. But you can see we're going to quickly run out of energy. We started with 2 million kilojoules of sun energy, and already by the third.
Oops, sorry.
So you can see that energy is quickly lost as it travels through the space.
Okay, so I'm going to pause it there. I want you to finish writing that out as your sample question. Now, once you understand that it's going to lose 10% each time, what you can do without doing all this multiplying math is just keep moving the decimal point. So if you notice, if you had the 20,000 and you move the decimal point over one space, because that'll be your 10%, then you end up with the 2,000. And then 10% of that is going to be your 200. And then if you get to the fourth level, 10% of that is going to be what? Somebody type in the chat for me. What would be if we went to level for this question only asks you for level 3. But if the question asked you for level 4, somebody who ate the fox, it would be 20%. Thanks, man. And then your apex person would be 10% of that. Okay. So what she's saying is, like you said, as you get to the top of the pyramid, there's less and less energy available for another. So this is why these energy, nature is wonderful about this. The apex predator is usually the last one, and nobody usually feeds on them. So they usually just die off for other reasons, but nope, they're not usually something that people, um, they're not usually the prey. Let me put it that way. Okay. And they have very little energy to pass on because they're using all of their energy. Okay. All right. Everybody has this, understands 10% rule. All right. So again, this is associated with our energy pyramid. So you bring this back up here, and all she did was put the numbers. And so you'll get word problems like that, where they will give you so many kilocalories and ask you to figure out what energy is available to whatever level they're looking for. Okay. All right. Take a few minutes to take 5 minutes to go through the check for understanding questions. And then as you answer each question, just keep clicking on the arrow till you get through all 5 questions. And then it'll give you a score. All right, while you do that, I have to update the attendance. I'm going to I'm going to look at that. That doesn't even have the nutrient PowerPoint. I think I was going to let it expire today, so it's not due today. So let me go in and fix that. So I'll stop sharing. All right. When you finish your practice for understanding, again, make sure that you understand that you will need for the AP exam, you will need to know how to calculate energy loss from each trophic level. You need to understand the 10% rule. And again, they'll give you the decimal number, but you can, like I said, cheat by just taking knowing how many spots you have to go up the pyramid and just move the decimal point over that many spots. Okay. All right. Take a look at, we've kind of talked about food webs and food chains already. Take a look at that while I look at the point that Gabriella just. Let me check and look at that in just a sec. So you all look at this and I'll try to answer Gabriella's question. As far as I know, nothing is due today. We did everything. Unless you have an outstanding assignment, nothing is due today. The PowerPoint had no points. I do need to check everybody's circle of life. And everybody has done it except Deborah. You need to do your circle of life discussion question. But other than that, nothing else is due today. The nutrients PowerPoint, I'm going to go ahead and remove that. And I just wanted it to be available. No, actually, it's not for grade. This is do not count as a final grade. Including, okay, and it's 0 points. I don't want to delete it so that you can't see it, but it shouldn't be in the grade book. So I'm going to take that out because it is in the grade book. However, it was in the module. Okay, that took that out of there too. I'll put it back in the module as a module unit and not as an assignment. All right, so it's no longer in the grade book, so it shouldn't show up as something that is due. All right, so at this time, there's nothing due unless you had an outstanding assignment. All right. Back to our module. So looking at food webs and food chains, and we kind of looked at that yesterday when we looked at the sample question, but I want to make sure that we go through all of those ideas again. All right, so as you see from our list, the next thing is the module study guide. Well, we're going to do a short quiz in a few minutes on food webs and food chains and producers. All right, so again, this is similar to the pyramid, except now we have pictures of actual organisms. So again, we have the sun at the beginning, and if you're drawing a food chain, you always start with the sun because the plants have to get their energy from somewhere. And again, this picture is representing feeding relationships. And you always start with a producer. So the first thing in your food chain is always a plant of some sort. The second thing in your food chain will be your consumers, and there are three different kinds of consumers. Your primary consumer would be the thing that eats the plant. Your secondary consumer is the thing that ate the plant eater. And your tertiary consumer would be, and sometimes is your last consumer, um, would be the thing that ate the plant eater. Okay. Now, the other thing you need to remember is that it does matter which way the arrows point. The arrows point in the direction of energy flow. So the energy flows from the thing that is eaten to the thing that it eats. So I think we talked about that yesterday. Now, what the difference between a food web and a food chain is that it represents a singular line of feeding relationships. So if you just wanted to look at one line, that's what you would look at. Most of the time, you're looking at a food web because organisms, in other words, in society, in an ecosystem, the grasshopper, or in this case was the caterpillar, is not the only organism that eats the grass. This one actually shows a grasshopper. Okay, this one shows a squirrel. So they have different things that are eating the grass. Okay, so you need to be able to follow the arrows and be able to read it in such a way. For example, you need to be able to say that the grasshopper eats the grass and the squirrel eats the grass. We need to be able to say that the squirrel eats the grasshopper because there's an arrow pointing from the grasshopper to the squirrel. So the squirrel eats both grass and grasshoppers. Okay. All right. As far as the squirrel is, actually the bird is also arrows pointing from the grass to the bird. So the bird is eating the grass. The bird is also eating the grasshopper. Okay, so this you need to be able to take this picture and translate it like that. You need to be able to go follow each of the arrows and be able to explain what the feeding systems are. All right, so then we look at our bird and we say that the bird is eaten by the fox. The bird is also eaten by the eagle. Okay, the squirrel is eaten by the eagle. Okay. But notice there's no arrows pointing to the away from the fox. There's no arrows pointing away from the eagle. So these would be our tertiary consumers or our apex consumers. They are the top of the food chain. Okay. All right.
Miss
So again,
Harris,
hello.
I hate to interrupt, but can I ask a question of the class so that I can kind of figure out where we are?
Sure.
I'm asking about testing, guys. I know it's way early in the year, but October 4th is priority or pre registering, or I can't remember what it is, but we have between October the 4th and November the 15th for signing up for testing. And I'm trying to figure out if y'all could give me a thumbs up if you're planning to take the test. Let me tell you, it's $99. And there is a possibility of a fee reduction if you qualify. So if you think you might qualify, contact me personally, text me or email me or whatever. And then I'll let you know how that works. Yes, this is for this class for AP. Right now I'm asking for AP Enviro. So if you are looking at taking the AP Enviro test, if you could give me a thumbs up, and then that way I can kind of go down and count. I've got one. No, ma'am. It's not required, but if you want the credit for college, it is required for college. All right, so I have one, I have two. Yes, if you could get back to me maybe like Monday or so, sometime next week, I have 2, 3, 4, 5. Okay, so by next week, if y'all could tell me for sure, you could let Miss Harris know or let me know. But one of us by next week, say by next Friday. Does that work?
Okay.
Everybody by next Friday, let me know if you are planning to take it. You don't have to sign up, but that you're planning to take the test. Does that make sense?
Put a note to ask.
Okay, so right now there's about 5 of you that told me that you are planning to take the test. Okay. All right. Thank you, Ms. Harris. That's all I had.
Okay.
Thanks, guys. Y'all are doing a fabulous job. I appreciate it. Thank you. Bye.
All right, so I made a note to remind me to ask you next Friday if you're still going to take the test. And again, as we go through each of these, at the bottom, it's important that we look at the AP tips and they tell you what's important. Excuse me. As far as the exam questions are concerned. And yesterday we looked at a sample exam question. Kind of looked like this. Okay. All right. So again, you need to be able, and then they do that. They give you a picture like this. And the whole question is based on, can you, excuse me, translate who's eating what? Which way is the energy flowing? So you need to be familiar with, for example, you need to know that phytoplankton are the plants or considered the producers in this type of system, that zooplankton are the microscopic organisms and they're going to feed on the phytoplankton. Okay, so again, looking at this diagram, and this looks very complex, but this is more realistic as far as what an ecosystem, what a coastal ecosystem is like. So not only are we looking at who's in the water, we're also looking at the birds that are feeding off of the things in the water. We're looking at some of the shrubbery that might be along the coast of the water. Okay, so all of that has to be considered in an ecosystem if we're looking at all the components and all the feeding relationships. All right, so they're calling this an interlocking pattern of food chains that depicts the flow of energy and nutrients in 2 or more food chains. So again, you can start with one plant. So right now we've got 3 different sets of producers here. Okay. And we can start with that and just take each one of those as a chain, or we can look at how many organisms feed on that one producer. All right, our herbivores, again, in this case, are the ducks. If the duck is eating the producer submerged in the water, it is considered the second level, second trophic level. So again, if we were doing this as a pyramid, it would be the next step up. All right. It says if it is eating the primary consumer, which is the bivalves, and I can't move this aside, but like our clams, the clams shelled organisms are bivalves. It is considered the third level, trophic level. So in other words, what it's saying is depending on which way you're going, it eating the plant makes it a second level, but eating the bivalves, which also which are second level by themselves because they also eat plants. If they eat them, that makes them a secondary consumer. Okay, so you have to look at it like that. Let's look at this one. All right. So this is, he says, you can see that the zooplankton are food for both small phytoplankton and for the bivalves. So again, the bivalves are feeding off of something other than the phytoplankton. Okay, so that makes them carnivores. So the zooplankton would be your primary and the bivalve would be the secondary consumer. All right, so let's look up here at this. All right, from the arrow from the duck to the eagle. Because the eagle eats the duck is providing energy for the eagle, so the arrow is drawn from, again, from the duck to the eagle. So again, they're just emphasizing which way to draw the arrows. Okay. All right, so study these, practice translating a diagram like this, practice trying to see who eats what. I might give you a practice question on that later on. Let's see. All right, I'm going to, let's see. So let's look at negative and positive feedbacks. So take a minute to look at this one. So vocabulary, so make sure you're keeping track of your vocabulary. Because when you do AP exams, they expect you to use the vocabulary. You can't make, do vague terms. You get graded on how many vocabulary words not only that you use them correctly. Okay. All right. So when a change brings about, when a change is brought about by a opposite direction. This causes the system to return to a previous condition. Most natural systems in the feed systems are negative. Click on it. Okay, so they want you. Okay. Okay, can't go backwards, can I? Yes, I can. All right, so we're looking at this. So a negative feedback would be when your body is not in an ideal condition, your temperature rises, your body slows down, you feel bad. Okay, you feeling bad makes you slow down. And usually what they tell you is you need rest, and the rest will bring the system back in order. So a negative thing causes an opposite reaction. All right, this one, if you get overheated, same thing. You get here again, optimal temperature. Organisms function at an optimal temperature. You get overheated, you get dehydrated, it causes a negative reaction. You stop functioning. Okay, so that's a negative feedback. All right, this one, in your house, if it's too hot in your house, you go over to the thermostat and you turn it down so that you can get a cooler atmosphere. That's going to raise your electric bill, which is also a negative part of that feedback. As far as I'm concerned, I don't like paying high electric bills. That's a negative feedback. All right. The mechanism in your toilet. When you pull the handle down, the water goes down because you open the flap. That's not the greatest example, but that's that. All right. Positive feedbacks. All right, so positive feedback do the opposite than negative. Instead of maintaining a balance, they exasperate the situation and cause it to continue going in the same direction. All right, so looking at these pictures right now, this is when the temperature rises in the human, they use the air conditioner, and sometimes that's not a good thing. Using air conditioners create more carbon dioxide in the atmosphere. More carbon dioxide has a negative effect on our greenhouse gases. It adds more. I think we talked about this when we were talking about carbon dioxide. The more carbon dioxide in the atmosphere, the warmer the planet gets, because the carbon dioxide is what makes our planet warm in the first place. It stuffs the blanket. So if you keep turning the air conditioner up and the air conditioner has to work harder, then it adds more carbon dioxide. And that's not good for the atmosphere. It's good for you because you feel nice and cool, but it's not good for the atmosphere. Okay. All right, let's look at the next one. All right. When the water, global warming causes the ice to melt, and then the ice blocks create these crevices in the land, and causes erosion, causes sea level to rise. So more carbon dioxide in the atmosphere is not a good thing. Okay. So this is when the soil is colonized by trees and shrubs, and more water evaporates, causes increased rain. So remember our water cycle, that trees transpire, so they are adding water back to the atmosphere. So in areas that rainforests are like this, the rainforests are really moist, and they're called rainforests for a reason, because you get a lot of rain there, because you have a lot of trees. Areas that don't have a lot of vegetation tend to be dry because they don't have the transpiration to add to your water cycle to cause the rain. Okay, so more trees might be a good thing. More trees means more water in the atmosphere and more rain and so on and so forth. So that's why it's a good thing. It's not a good thing. Too much of a good thing is not a good thing. Okay. Same thing with these plants. And this is during labor. You want the release of the hormone to cause the contractions, and the pressure on the cervix causes more release. And eventually delivering the baby is a good thing, but don't think the mother feels that way while the hormones are causing the contractions. Okay. All right. So that's that. I was going to let you do a short quiz, but I don't think you have time to do it. Let's see. I think you can do it. All right, so give me a second to get the code for you. Yeah, you could do this. This is short. All right, and I will print this as a grade for today. All right, there it is. All right, so I will be waiting for 10 people to log in, and then I'll start it. All right, so hopefully some of these, two places I'm looking at the ceiling. Hopefully you're still there. But I have just put the code for the quiz in. Everybody needs to take this quiz. It's for a grade. While I'm waiting for 10 people, when I get most of you in, I'll go ahead and get started so that you have time. Right now I have 6 out of 10. So if you're not logged in, please log into the quiz. Thank you. Uh, let's see, I got Kamari, I got Journey, got Van, Ethan, William is in, Deborah, you're not in, and Ariana. All right, so like I said, I'm gonna go ahead and get started. Deborah and Ariana, you need to get in as soon as possible. Deborah, now it's just you. Oh, there you go. Okay. Missing somebody then. All right, Gabriella, you're not in. Thank you. All right, ladies, this is for grade. You're in, but you're not doing the quiz. Doing.